So this is Dan Frantz with the Kurz Industrial Solutions Wind Division podcast. I have on the line Kumar from Federal-Mogul. He has the product Diva Pucks, which we've seen a massive increase in consumption and usage and positive feedback from our customers. And I'm sure Kumar has also seen that in the field since he's the main point person here in the United States for a lot of these end users utilizing the Diva Pucks. Kumar, for the two people in the industry who don't know you, because you're a very well-connected guy, could you give us a little bit of your background? How'd you end up at Federal-Mogul, and just expand from there?
Yeah, hi Dan. First of all, good afternoon, and thank you for taking the time to speak with me. So also I appreciate your input on the Diva Pucks. It's very nice to know that the market really enjoys the Diva Pucks, especially the end users. A little bit about my background is I'm a mechanical engineer. I've been with Federal-Mogul for 16 years, and I'm involved with many markets such as offshore marine, which means oil and gas, hydropower, gas steam, wind turbines. So we have several applications, and wind market is of course a growing market and a very important application for us. So yeah, I'm excited to be here.
Kumar, could you tell me a little bit more about the wind market itself? You've been with Federal-Mogul for 16 years. That's impressive, especially nowadays. What have you seen in terms of the evolution of the wind market from 16 years ago to today? And ultimately, what do you like about working with the wind sector in general?
Yeah, I mean, the winds market sector, I've been actually involved for maybe around, I would say, 9 to 10 years. I was not always doing the wind. So we started with the GE turbines for the rotor locks as well as for the yaw pucks for the wind turbines. And what we noticed is the trend to for the end users to go from composite materials to the metallic materials. So that's the trend that we saw with the test results with several end users. And of course, there are many advantages, whichever the Diva pucks, that's what end users liked, you know.
Sure. Could you maybe talk about the differences between composite to now the metal and just different material types, and what do you think caused people to move away from composite?
Yeah, you know, Dan, we have, of course, competitors, and I don't want to say anything about the competitor materials. I can talk on the behalf of the Diva pucks. We also have metallic pucks as well as composite pucks at Federal-Mogul. But in North America, the success is seen with the Diva pucks, especially in eliminating the fog horning issues. For example, you know, the noise that is like a rattling noise, similar to if you move a table and you hear this rattling effect. Same thing with the fog horning issues, which can drive the neighbors crazy, you know, in a winter, if the wind turbine is loud like that, right? So the fog horning is caused by the differences in the friction between the static and the dynamic coefficient of friction. But with the Diva products, because of the material composition, our static and dynamic coefficient of friction are very similar. So that's one advantage of the Diva pucks. And then the second advantage is the long wear life, which means our estimated wear time is easily around 7 years plus. In some cases, we're getting 10 years plus. So there's different scenarios on how the turbines are being maintained by the OEMs or the end users. So that's another benefit. And again, talking about the coefficient of friction, you know, we meet the requirements from the OEMs about the coefficient of friction. Metallic pucks are dimensionally more stable. That means we do not really experience the cracking or the delamination issues which some of our competitors unfortunately face in the market. Other advantages, the ability to use the grease or not to use the grease. So some of the customers will use grease, some will not use the grease with the Diva pucks. It's dependent on the individuals or the end users, wind farms, how they maintain their turbines, but it does not cause any drastic effect on the Diva pucks. It just prolongs the lifetime. So there are several benefits to this. Regarding the composite pucks, we can make those too. From what I hear, they're pucks made of Teflon, and there are pucks made of organic materials, fiber based. Some may be fabric based, but I don't have enough information on those.
No worries. And would you say, and feel free to disagree with me, but from what I've seen, a lot of people are moving away from the composite and going towards the metallic pucks. Would that be accurate?
Yes, yes, I have seen the trend, especially the OEMs are also trying to gear into that direction. I cannot specifically say which OEM, but the trend is that after seeing the performance of the Diva pucks in the industry and also seeing the results for many, many years, the end users itself are putting the pressure on the customers to change the direction.
Interesting. And so obviously, I haven't been in wind for 16 years. I'm also not a mechanical engineer. I think a lot of people who tend to listen to this podcast or read the content aren't at the level that you are when understanding the technical terms of the Diva puck. You had
Mhm.
mentioned the coefficient of friction. For somebody like myself with a walnut brain, could you break it down into simple terms? What is the coefficient of friction, and why does that matter when it comes to foghorning and wind turbines?
Yeah, so in the wind turbine, you're basically using the Diva pucks, for the braking functionality. So you can think about your car. If your car, does not has a brake, how it will be like for somebody to drive. So similarly, you need some kind of braking mechanism with the yawing motion of the turbine to have some kind of brakes. So if you have a braking material, that means you will generate friction, right? So the concept is similar. So you need the friction in order to stop or start the direction of the turbine. So depending on the direction of the movements, for example. So uh, of course, the coefficient of friction is dependent on the load. So if you think about a sliding disc or area where you can actually put the load, and that load is reflective on the surface pressure area, so there's always any movement that is generated, there's a coefficient of friction that takes place because of this impact. So similar to a brake. So I hope I can give a little bit better explanation. I hope it was enough.
Yeah, definitely. So just to clarify here, and that was a fantastic explanation, is there a sweet spot of friction that you guys have been able to test and engineer with this puck? Obviously, you want some friction, but then too much might lead to other issues. Am I thinking about this appropriately?
Well, in the wind turbines, you need actually like higher coefficient of friction. Now, typically, the Diva pucks are self-lubricated materials, which means we have homogeneous dispersion of solid lubricants like graphite throughout the metallic matrix. But the coefficient of friction is dependent on the loads. So in the case of wind turbines, the loads are not so high for the Diva materials, and also it's like pulsating and impact loads, mostly. So, after certain cycles, I guess. So there are certain requirements of coefficient of friction from the OEMs that they ask for the loads that they want us to test with, and the loads that generate this coefficient of friction are in the range of zero point 0.3 to zero point 0.4 range. That's the coefficient of friction that is required in this application, and we're able to generate that.
Oh, that's fantastic. Now, we're talking about the coefficient of friction. We talked about foghorning, longer wear life with the Diva puck, 7 to maybe 10 years plus. You're not going to see cracking. You can use it with or without grease, depending on the OEM. Ultimately, Kumar, who do you think is a good candidate to try out the Diva pucks today? Um, and maybe you can elaborate a little bit more clearly on that as well.
Yeah, absolutely. A good candidate would be somebody who is experiencing, let's say, issues with their existing pucks, or they have problems with their wind turbines at the moment. And also somebody who just wants to try a different material, different technology, somebody who's saying that, hey, I've used composite materials, I'm getting maybe 3 years, 4 years lifetime, but I want to try something, which can give me a longer lifetime. Yeah, my cost may be higher, but at least I know that I don't have to go up and down so many turbines for the maintenance. So it's a return on investment to the people who want a longevity and also maintenance-free operation. Somebody who's looking for reliability, somebody who's looking for performance-based materials. Those are the ideal candidates for the Diva pucks.
And this is, from my perspective, being out in the field weeks and weeks on end. Every week I typically travel to different wind farms. I would say 90% of our customers at Kurz are running into those types of issues. So I think this is a really large problem in the field, and I use problem semi-lightly because people are looking for a better solution, a longer return on investment when it comes to their yaw pucks and their yaw components. So I think you guys at Federal-Mogul have done an incredible job engineering this product, and again, the feedback that we've gotten from the field has been fabulous. I think a majority of our customers now have moved over to the Diva pucks, and it's for all the reasons that you've just alluded to. Now,
Oh,
Kumar, I'd like to hear also, we talked about the Divas. Federal-Mogul and this particular yaw system has other products that you guys do offer. Do you want to talk about maybe some other yaw pistons or other products that you guys also do offer to customers outside of just the Diva puck?
yeah, absolutely. There's many things that we can provide for the wind turbines. So besides the metallic pucks that we mentioned, which is typically used for passive braking system. We also can use these metallic pucks for the active braking system. That means the use of hydraulic cylinders instead of the springs, which is for passive braking system. So we have also other materials, like I mentioned. In general, we have about 100 different alloys that we can use if we really want to supply. But we have composite materials, for example, in some turbines in Asia, which use our composite materials in the form of segments, radial segments, axial segments, similar to the designs that are done in Asia, for example. We also supply the rotor lock bushings, mechanical or hydraulic. So this is the other component that we can help with. And then also we can help the customers with the pitch systems, like the hydraulic pitch systems have the Divatex or composite sleeve bearings. So these are also self-lubricated. So we can even provide those. And also we can help with the low speed shaft transmission, but we have to look at the data and kind of do like a reverse engineering. So there's, of course, many applications, but I would say that the pucks is obviously the most important business that we see from the market.
Absolutely, and I would tend to agree with that. Now, last question for you, Kumar. This is a little bit outside the scope of Kurz or Federal-Mogul, but I'm always curious to ask our guests on the podcast about their vision for wind in the future. Now, I know that you dabble with a lot of different markets, but I'm curious to hear what you think wind will do and evolve over the next 10, 20, and 30 years. Meaning, is it going to be more offshore? Do you think the output of these turbines will be larger? How will the components change? And even culturally and politically in North America, how do you see the adoption of wind over the long haul?
Right. Yep. Absolutely. So wind is still like an emerging market. It is not reached its potential, and there's still a lot of room to grow in this market. And of course, government is also trying to push for it. And from what I see is the offshore wind is also going to be a massive thing in the future, because especially states like New Jersey, New York, Rhode Island, they're going to be spending a lot of money, in billions of dollars, on the offshore wind. So this is just going to increase, and I can only imagine that the size of the turbine is going to increase. I'm sure it's going over 3 megawatt plus already. We're talking about 5-6 megawatts already. So that means the size of the pucks, for example, may change. The other dimensions may change for the sliding bearings. So there's a lot of possibilities to grow. 20 years from now, there's going to be also a lot of refurbishment business and new turbine development business also.
Kumar, do you imagine there's going to be more manufacturers that come into the market and enter the market, or do you see more of a consolidation of all these different manufacturers, similar to what we saw with, for instance, Siemens buying Gamesa, or Axiona and Senvion merging.
Mhm.
What do you think is going to happen here in the future? More of a consolidation or more manufacturers trying to get into the renewable sector?
Yeah, I mean, it's a possibility of both. I mean, it's kind of hard to say. There's always mergers happening, in the market. I would say, more foreign companies are going to try to establish the base in the United States, looking for the local partners, strategic alliances, and also the distribution business will grow. And the OEM business is also going to expand. So it's kind of tough spot to be in to speak so ahead of time, but I think the potential is just immense.
Yeah, that's awesome feedback, and I would tend to agree with you on all fronts. Now, Kumar, we appreciate your time today. I certainly don't want to take up too much of your time, but for people who maybe want to get in touch with your brand or get a better feel for the components that Federal-Mogul does sell for their turbine applications, different turbines, and OEMs, where can people find you?
Yeah, people can find me on the website of Federal-Mogul, www.deva.de, or they can send me an email at Kumar, Kumar dot Nainani at Federal Mogul, one word, which is FEDERALMOGUL.com, or I can be reached on my phone, 330-329-7733.
Awesome. Well, Kumar, I'll make sure that we do put all of your information here underneath the podcast, along with the blog that tends to go along with these conversations. Again,
Yep.
sir, you could be doing a lot of things this afternoon, and this afternoon you chose to sit down with me and talk about your product line, which we really do appreciate. We do appreciate the partnership with you guys over there at Federal Mogul. For people listening, Kurz also does stock the Diva Pucks, and we're a huge believer in the product and the technology, and we've put a lot of faith in Kumar and the technology that Federal Mogul has developed to pass on to our own end users. So get in touch with Kumar. If you have any more questions, you could also get in touch with Kurz. We work closely with Kumar and Federal Mogul. And in general, sir, thank you for your time.
Dan, thank you so much again for taking the time to, ask me these good questions. And we also appreciate working with Kurz, and thank you for your support in educating your customers to consider the pucks not just on the price, but also on the performance and reliability on the field. So we appreciate the efforts that Kurz is putting into the field and spreading the word in the market. Thank you so much.
Absolutely. Well, Kumar, I appreciate the time today, sir.